which indicates to me that your brains are hitting on all 4 cylinders. We got practice. I can make these up all day. I love this stuff. And you will too. Or die trying. So let's do another one. Since we like pi, pi is kind of fun. What is sigma k equals 1 to infinity of pi to the k plus 1 over pi to the 2k? Oh, I'll just make it easier. How about if I just do this? We'll start that way. Converge or diverge? Okay, Baba says it might converge. Why do you say it might converge? Okay, let's manipulate this so it looks friendlier. I have sigma k equals 1 to the infinity of
2 of pi.
This is pi over k times pi to the k squared. So how can I rewrite that? How about if we write that pi over k times pi over k? So this is sigma k equals 1 to infinity of 1 over pi to the k. Converge or diverge?
Wait, pi over k is the same thing as pi over k squared is the same thing as pi over 2k?
Yes, because I can rewrite this as pi to the k squared. Yes?
Yeah.
Which means this is pi to the k times pi to the k by the definition of what it means to square something.
No, I meant the beginning part says pi to the 2k.
Yes.
That's okay.
Pi to the 2k equals pi to the k squared. 2 times k, right?
Okay.
How do I rewrite this?
Okay, yeah, I get that part. Okay.
You guys gotta work on your algebra for this stuff. Man, if algebra kills you in this section, I'll slap you. This is algebra 2, people. What did I say about having to remember everything? To remember everything I ever taught you. You're in calculus now. So, does this converge or diverge?
Might converge.
It might converge. How can we know if it converges or not? Let me ask you a question. If this were sigma k equals 1 to infinity of 1/4, I'll write it this way. Why? Yeah. See, why is this tripping you out? It's tripping you out because you don't like pi. So don't think of it in terms of pi. Pi is just a constant. It's a number like 10 or 2.5 or 19. It's just 3.14. Okay? So what if I put 1 over 3.14 to the k in there? I have a common ratio. What's my common ratio? My common ratio is pi. This is a geometric sequence. I am multiplying each term by pi. The fact that pi is a nasty transcendental number doesn't matter. It's still a constant. It's still a geometric sequence. Are you with me? Now, the reason I'm going through these, I could have written this as 3 to the k over 3 to the 2k. I didn't want to do that. Why didn't I want to do that? Because I'm trying to get you to not flip out just when you see constants. You're going to be dealing with E. What is E?
2.7.
It's 2.7. So if looking at E bothers you, think of it in terms of 2.718. If pi bothers you, think of it in terms of 3.14.
Wait, how's the ratio? The common ratio is pi.
Work with me. Put 1 in here. When I put 1 in for k, what do I get? I get 1 over pi. When I put 2 in, what do I get?
1 over pi squared.
1 over pi squared. What's my next term?
So it should be 1 over pi, not pi.
Yes, the common ratio is 1 over pi.
You said
You said
pi.
pi.
And that way.
I'm sorry, the common ratio is 1 over pi.
Okay.
Yes? So the common ratio is 1 over pi, so let's figure this out. We have a formula. What's the formula? Okay, for a geometric sequence. A sub 1 over 1 minus r. So let's put 1 over pi in. What's our first term? 1 over pi over 1 minus pi.
1 minus 1 over 5.
Oh, thank you. I did it again. So let's bring this down to the bottom. Let's see if we can just simplify this a little bit. So I have 1 over pi times 1 minus 1 over pi. Let's cross multiply this in common. Well, if I multiply this by pi over pi, I get 1 over pi squared minus 1 over pi squared, which is 1 pi over, the pi squared is going to go on top. Pi squared over pi minus 1. So what does this sequence add up to? Pi squared over pi minus 1. Yes? Can you do this? We got 5 minutes left. I'm going to turn you loose. We'll pick up next time on harmonic series, and we'll get a lot more practice doing this, and we'll start getting some theorems, more theorems for helping us with convergence and divergence.